Hi guys, what I want to do today is just kind of get you started on your worksheet. I know some of you in class, we got further on this worksheet than others, but this ended up being part of your homework. So what I want to do is just re-explain for those of you that might not have been in class. The top of the worksheet here, we have some constants, some formulas, and then a little key that I've titled for you here to kind of explain some symbols you're going to see in your thermodynamic formulas here. So three constants that they've given you is the heat of fusion of water. This is a constant value, so it has unlimited sig figs. The heat of vaporization for water, again, a constant, so it has unlimited sig figs. And the specific heat capacity of water, which is a constant, again, has unlimited sig figs. I also wrote their symbols over to the side. And then here we have our formulas that relate them to each other. The key over here indicates that the little m in your formula, you see it in each formula, represents the mass of your substance. And this mass will typically be in grams because if you look at your constants, they have a gram unit showing up here. C is a specific heat capacity. And then the T, capital T, stands for temperature. Now, when you read your problems, if you do not see a change in temperature, that means that it's occurring during a phase change. So that's when your heat of fusion and heat of vaporization will be being utilized. And let me just remind you, we just finished up the chapter where we studied about phase changes and your heating curve and your cooling curve. So just want to remind you of the general shape of that. On your heating curves, you have two plateaus. And during the plateau region, your phase change region, that's where you have two states of matter. So like for here, we have the liquid in equilibrium with the vapor. And on this plateau, we had the solid in equilibrium with the liquid. But what we said is during the phase changes where there's no temperature change, the temperature remains constant, we have energy being either absorbed or released, depending on if we're heating it or if we're cooling it down. But this is where you have up here the heat of vaporization being absorbed or released. And here during this phase change is where you have heat of fusion. So those constants are what are given here in your table. All right, so let's take a look at number one. It says calculate the number of grams of water at 100 degrees Celsius that can be changed to steam. So water being a liquid changing to steam, this is a phase change at the same temperature. Notice there's no temperature change. So this is referring to the phase change taking place here on this plateau, heat of vaporization. And they tell you that 76,820 joules are added. So the formula that we want to use, since this is dealing with the vaporization, is the Q equals the mass times the heat of vaporization. So remember, always write your formulas down. Then we're going to plug into the formula, and we're looking for the mass. So the grams of water is your mass that we're looking for. Now the Q is what is represented here with the 76,820 joules. That is our energy. So 76,820 joules of energy. We're solving for mass, and then the heat of vaporization is a constant, so we're going to plug that number in, which is 2260 joule per gram. Now notice here that your units, the joule unit, will cancel. So we're going to have to divide both sides. To isolate our variable, we're going to divide both sides by 2260 joule per gram. So what that's going to do is it's going to let it cancel on this side, and also on this side allows joules to cancel. And so that isolates our M. So the mass is going to be equal to 76,820 divided by 2,260. And so that's going to leave us with an answer of 33.99 grams for the mass. We need four significant figures here because our constant has unlimited sig figs and our given has 4 sig figs. Because there's no decimal in this number, that 0 doesn't count. All right, let's look at number 2. It says how many grams of water, looking for the mass of water again, can be warmed from 7 degrees Celsius to 97 degrees Celsius by the addition of 32,886 joules. So notice here there is a delta T. It's a temperature change, which means this is occurring during the part where the temperature is rising. There's a change in temperature. So this is on your heating curve during one of your sessions where you have one state of matter. So the water's being warmed. It's not undergoing a phase change. So we got to find our delta T. Now remember, delta T is equal to the final temperature minus the initial temperature. And this is important to take note of. So it's warmed from 7 to 97. So the final temperature is 97 degrees Celsius. And we're going to say minus the initial temperature, which is 7.0. And that's going to give us our delta T. And in a second, we'll plug that into our formula. Q equals MCAT. So when you subtract here, remember, go at least decimal places. This has no decimal places. This has one decimal place. So we're going to round this answer to the whole number. So let's go around to 90 with a decimal. Put your decimal point there so you'll keep your sig figs intact. Okay, so there's your delta T, 90 to 2 sig figs. Now we can plug into the formula. Q is equal to MC delta T. M times C times delta T. So the Q, they added 32,000, that's going to plug in for Q, 32,886 joules. And it wants to know how many grams, so we're looking for mass again. The specific heat of water is given here. It's a constant specific heat capacity of water. We're going to plug that in. So that's going to be 4.18. Some tables will give you 4.184, but we'll use what this one is given, 4.18, and that's joule per gram degree Celsius. And we found our delta T here, so we're going to plug that in, 90 with a decimal degree Celsius. Now watch your units. On this side, the Celsius temperatures cancel. Now to isolate our variable here, we're going to have to rearrange, and that's going to give you 32,886 joules divided by 4.18 joule per gram degree Celsius and divided by 90 degrees Celsius. And that will isolate your mass. Again, what's your unit? Joules divide out, Celsius divides out, so you're left with a unit of grams. So we end up with our mass. And again, look at your sig figs. Our given had a total of 5 sig figs. This delta T has 2 sig figs, and our constant has unlimited sig figs. So we're going to round our answer to 2 sig figs. You should round this to 87 grams. Fantastic. All right, let's look at number 3. I'm not going to do this one with you completely, but just to kind of talk about which formula. It says, what is the final temperature of water if 380 grams of water at 36 degrees Celsius absorb 47,880 joules of energy? So let's identify some things here. Okay, it wants the final temperature, so it means there's a temperature change. So we're going to be using Q equals MCAT. And I'm going to kind of expand the delta T once we solve for that variable, and then we'll kind of expand it out. Remember, delta T is equal to T final minus T initial, and this is what they're wanting us to find, final temperature. So we're going to first use this. So the joules is our Q. Joules is a unit of energy, so 47,880 joules equals, and the water, the mass of water is 380 with a decimal grams. And the specific heat of water is our constant, 4.18 joule per gram degree Celsius. And then that's times delta T. So what we're going to solve for first is we're going to find delta T. So to solve for delta T, of course, you're going to divide both sides by 380 and 4.18, and that'll give you your delta T. And then once you get your delta T, you're going to come to this formula, and you're going to solve by plugging in your answer for delta T here, and then your initial temperature here, which they gave you. On the last example, there is no temperature change. So here they're talking about the freezing and melting. So you're going to use the formula here. Q is equal to M times H of F, and I'll leave that at that. Okay, don't forget to do the back side of this and your other 3 problems. I hope this helps for those of you that were absent.